So I'm going to give you an introduction about CSP and also share some of the experience with deploying CSP at Yahoo. And also introduce some tools which probably will be useful for you related to CSP. So let's start CSP, Content Security Policy. So we cannot really start talking CSP without mentioning cross-site scripting. So what is cross-site scripting? So cross-site scripting is execution of malicious code injected by an attacker on victim's web. I just have to one second. Anyway, sorry about it. So what is cross-site scripting? It's basically a execution of malicious code injected by an attacker on victim's web. So I would say cross-site scripting is kind of a mosquito of the web. So it can create some annoyance, itching on your surface, and can also it can become very dangerous. So for example, like if you have an XSS, it can lead to credential theft. For example, if you have you can set up a form and they can take your credentials and submit to the evil.com. Or they can read your emails if it is your application's email service. Or it can do malware distribution, it can do site defacement. So there are a lot of things it can do. So many times it's okay, but at times it can get very dangerous. So what is the primary reason? The primary reason is improper utilization of input when we render on a web page. So that's the primary thing. So you are taking input, and when you render it on the web page, and without neutralizing the input, then you'll get a cross-site scripting. So there are three different classes of cross-site scripting. One is a reflected, another one is stored, and DOM-based accesses. So the reflected accesses work when the user, when you pass some untrusted input, which server take it and insert into a web page and return it back to browser, and the code get executed on your browser. That's kind of reflected. You pass the input, that reflected back to a browser, and get included in your web page. In the case of stored accesses, it's very similar, but it gets stored in the web server and get inserted into different web pages. For example, like if you are reading an article which supports some comments, right? I put some comments, and when you read the same article, you can see the comment in that article. So if that comment section is susceptible to accesses, then your code gets executed there. And in the case of DOM accesses, it's directly manipulating the DOM in the browser side. So you're taking the input and injecting into your DOM, and that is causing some DOM accesses. So it remained as a top threat in the OWASP top 10 list since its first publication in 2004. So it's been there for a while. We know about this at least for more than a decade, this issue. And let's see what are the remedies. So since we know about this problem for a long time, and we have some remedies. The first thing is input validation and output encoding. So the input validation is whenever the data enter into our application, you need to make sure that the data is valid. For example, like you are taking an input, phone number input. That you have to make sure that you only accept numbers and from some optional hyphen or something like that. So you really make sure that it is validated. Another thing is output encoding. So the whole thing about XSS is related to output encoding. So the output encoding is you're taking input and place into HTML. So when you place your content into HTML, then context matters. So the context of the where you're placing the HTML, that's very important. For example, like if you're placing the data into an HTML context, then you need to do HTML encoding. Whereas you're placing the data in the JavaScript context, then you need to do JavaScript encoding. So that's why I said improper neutralization. That's the main thing about cross-site scripting. So the cross-site scripting we can completely solve if you are really doing the output encoding. And the second thing is whitelisting trusted contents and tags. So basically, if you are a publisher, then you need to depend upon a lot of context from a third party, or you need to put a lot of tags in your site. So one way is you need to whitelist based on some security review, and also some legal agreement exists between you and the third party. And the third one is isolation, because in many cases we cannot really control the input or the data. In that case, we isolate using frames, for example, like placing ads. So you place ad in a separate, say, 5 frames. That in that way, your application is not affected by displaying the ads. So this is a graph of CVEs disclosed XSS vulnerabilities for last 15 years. You can see the XSS is still prevalent. It's not really reduced. For last 15 years, at least for last 10 years, it's pretty much there are a lot of CVEs disclosed. So now you understand that with all these remedies, we still have this problem. So what is CSP? Content Security Policy. It's an additional layer of protection. It is not going to replace the existing traditional remedies or mechanisms, because you still need input validation, you still need output encoding. And this is an additional protection which prevents this vulnerability being exploited. That's the thing. It is not going to stop, it won't fix XSX, but it just prevent it. So let's look deep into CSP. So what is CSP? CSP is a browser mechanism that allows you to whitelist set of locations from which your application can load resources from. So, and CSP is completely backward compatible in the sense that even if your browser is not implemented CSP, it is not going to have any side effects. It won't work, but it won't have any side effects. So that's a good part. So you can specify a policy on a web page with a CSP HTTP header, something like below. So this is the name of the header called Content Security Policy. And this is called directive. Directive says that this is a default source which says that, oh, this application can only load resources from example.com. So your application can have a lot of resources like images, iframes, and scripts, style sheets. These are all kind of resources which is part of your application. So now we are whitelisting this as your domain from which you can only load resources. Or if you are trying to load the resources from a domain which is different from example.com, and that means it's violation, and browser will trigger a violation and will get reported back to our endpoint if you have mentioned it. So now let's talk about policy delivery. So how the policies are delivered? There are two primary mechanisms through which you can deliver policy. And the first one is you can use HTML meta tag to specify a content security policy. So if you are using meta tag, then you need to, the meta tag should be placed on top of the HTML page. And one thing really I want to note is Firefox has not implemented this feature, meta tag thing. So the recommendation is not to use only for testing, and for real production thing, you always use HTTP header. So the second mechanism is to use delivery or using HTTP header. So this is a HTTP header name. There are two modes of operation here, policy delivery. One is content security policy, that is enforce mode. So you're putting a policy, and if the browser finds a violation, is going to block it completely. That's called enforce mode. But there's another mode called report only mode. It's basically used for monitoring. So it's kind of dry run. It's not going to block anything. So let's say if you want to try out CSP on your application, and it's very easy, report only mode probably will be a good way to go, because it's very easy for you to convince the product owner saying that it's not going to have any kind of malfunction just by enabling it, because a dry run is not going to block, but you still can learn a lot of information by setting up in a report only mode. I'll show you an example. So here is a page I'm trying to protect. It's a test.html. And I'm going to apply this CSP policy. This policy directive is default SRC itself. And there are two directives here. One is default SRC, another is a report URI. So what does it mean? So the self means you can load resources from the protected resources origin. So essentially self means in an alias of your protected resources, example.com. And report URI is endpoint where the browser or the user agent send reports to if they find any violations. So let's see what will happen. So here you're trying to open this page in your browser, and you can see an image which is loaded from a location which is not, it is different from self, I mean which is different from this. So you definitely expect a violation because this page is trying to load a resource from a location which is not whitelisted in the policy. So when you try to load it, it throws a violation error. You can see it in the web console. So this is the overall idea, and this is how it works. So now, when the browser encounters a violation, it sends a violation report if you provided a report URI. And let's look into the violation report, how it looks like. So the violation reports are in JSON format, and the fields are kind of self-explanatory, but I'll go over it. So document URI is the URI you are trying to protect, or the web page you are trying to protect, where you place your CSP policy. And the referrer is referring is a regular referral thing. What is referring this document URI? If it exists, is there. Otherwise, it will be empty. And the blocked URI is the ones getting blocked because it is not there in the whitelist. And violated directive is the directive which is applied and found that it's violated. And the effective, I'll talk about effective in a few minutes because we need to talk about separate resource-specific directives. So original policy is the one you set in the CSP. So this is very interesting because we have encountered cases where original policy is actually the original policy as seen by user agent. So many times it is not as same as the policy we set because the policy at times get modified by some browser extension. So you expect this policy is as same as the one you set in the headers, but that might not be the case always. At times we have observed that it differs. So that's a very useful tool. So now we'll talk about content security policy directives. So we have the policy, policies are expressed. CSP consists of set of policies or directives. And the directives, so we have separate directives. Yeah, so CSP consists of set of directives, and each directive corresponds to a specific resource type. And you can see here, this, for example, is a script SRC is a directive which basically control what resources you can load, what JavaScript you can load. So script SRC directly corresponds to the script tag. So essentially, the script source contain a set of whitelisted location from which you can load and execute scripts. The same with the image SRC, which basically restrict from where you can load the resources from. The same for media. Media is basically correspond to audio and video tags in the HTML, and you can really control audio and video and its associated text. Child SRC determine what iframes you can put in your HTML. So it's basically an iframe. You can whitelist these domains or location from which you can have iframes. And the connect SRC is the AJAX thing. So you can whitelist the places where you can make a call, AJAX call. And also used for event source, that is a push notification thing, and web sockets. So it's a kind of fine granular kind of thing, and you can use all these tags to have fine granular resource control, like from where you can load resources from. So there is something called default SRC. So default SRC, if we don't have resource specific directive, then it will fall back to default SRC directive. So it applies to, if any of these things are missing, then it will fall back to the default SRC directive. So we have more directives. So the one is base URI, is for document base URLs. You can whitelist here. And form action, this is something, base URI, form action, most of the things here are actually added as part of CSP2. I'll talk about CSP2 soon. So the form action basically control where you can submit your form. So that's what I said initially, like the CSP, you can exploit a CSP, put a form which exactly look like your login page and accept user input, username, password, and submit to evil.com. So here with the form action, we can really control where and all you can submit the CSP page, where and all you can submit the form actually. So one thing. And the second one is frame ancestors. This is also part of the CSP2 and it's very useful and important because you probably would have heard about click jacking and you use X-frame options. So this is an alternate way of specifying who can frame your page. So it's a very useful tool and actually this deprecate or overrides X-frame option. So going forward, if at all if you are using X-frame option, then probably this probably will be a good option. Plugin type, this is also part of CSP2. So here we control what kind of plugins you want to support. For example, like Flash, Microsoft Silverlight, PDFs. So you can really whitelist what you really want. So you would have seen like a lot of Flash vulnerabilities, all those things. So if you want to disable Flash, then you exclude it from your whitelist. In that way, Flash won't get played on your web page. Sandbox attribute is very similar to an iframe sandbox attribute to put some restriction on what you can run on your iframe by controlling, by creating some unique same origin and restrict JavaScript, restrict form submission, things like that. Report URI specify the URI to which user agents send reports about policy violations. So for keywords, so there are certain keywords. I already introduced a keyword called self, so you have some idea about what our keywords are. So we have more keywords. So I'll go over the keywords. So the first one is none. So if you set, let's say for example, default SRC none, that means your application is self-contained and you cannot make any external request. So if you have an application is completely kind of self-contained, then this is a very good option. And self, essentially restrict access to applications on origin. So you cannot load resources from a location outside of the application's domain, application's origin. Unsafe inline, that's interesting. So CSP by default would not allow inline script and style. So what is inline script and style? It is a mixing of JavaScript style within HTML. So it is because of security reason. I explain in next few slides. So the unsafe inline is basically relax the restriction and allow you to have inline script. So the reason why you need to allow is because there are a lot of legacy applications which have inline JavaScript and all. So to at least to start, probably you need to relax the restrictions so that we need to use unsafe inline. Unsafe eval the same way, it won't allow eval, set timeout, function constructors. So the unsafe eval basically relax the restriction. There are many cases where your application depends on some framework or some third-party framework which may use these functions internally. Even though if it is a safe manner, it will throw an error. So this will relax essentially those restrictions. Wildcard, as you know, it's basically in this case default SRC star means there is no content security policy. Essentially means it's as same as no policy. So we'll go over CSP versions and browser support. So we have two major revisions with CSP, the CSP1 and CSP2. The CSP1 is released or available since 2012 and is available on all modern browsers, including Chrome, Firefox, Opera, Safari, and Edge. There is a very limited support on IE, but it is very limited. And most of the fetch directives are part of CSP1. And the CSP2 is released very recently, a couple of months back, and add all the interesting directives such as form actions, frame ancestors, plugin types, are all very useful plugin directives. And it's also deprecated frame source in favor of child SRC. So the browser support, Chrome 2 browser support is available in Chrome. CSP2 support is available in Chrome, Firefox, and Opera. And it is not right now available on Safari and Edge. Now look at some examples, and let's see. So here, so you are going to have a policy you set on CSPexample.com. And the policy says that default source is self. I mean, it's the default source to same origin. And now you're trying to load a JavaScript. So now you have to tell me whether this is a violation or not. Is this going to have a violation? Can you take a guess? Yes or no? Okay, it's correct. There is no violation here. What about this? No? Yeah, that's correct. And what about this? Why? Yeah, HTTP, that's correct. And what about this? Is going to fire a violation? Yeah, yes, it's going to fire a violation because domain is different. What about this? Yes, because the port is different. All right. So I mentioned about unsafe inline. So why CSP is not allowing inline JavaScript? So I'll explain you. So let's say you have a PHP script which take a user input and insert into your page. Okay. So that's what is happening. So you have an endpoint which take a username equal to something, and this is your PHP script. So you can see here, it is accepting the input and placed into HTML code, which is generated by the PHP. So actually this is vulnerable because we are not really validating the input. We are completely, the PHP blindly taking the user input and placing HTML. Now here is HTML file generated by the PHP script, which get loaded into your browser. Now you see how the browser can identify a legitimate JavaScript with an injected JavaScript. It is almost impossible to identify unless you give some clue, correct? So that's a problem with the inline JavaScript. So for browser, it's very difficult to identify or differentiate between these two scripts because this is a legitimate script and this is an injected script. It's very hard to figure out which is good, which is bad. So that is a problem with the inline JavaScript. How can we solve it? The recommended practice is to externalize inline JavaScript and style. So you need to pull out the JavaScript and put it into a separate file. But the problem is, if it's for existing application, it may involve significant effort because there will be a lot of pages which are kind of inline. And in addition, some people argue that you still need to keep some inline JavaScript, mainly because notably for performance, page load latency, things like that. So in that case, we probably won't be able to completely externalize all the inline JavaScript and CSS. So what are the solutions? What are the other solutions? Other solution is unsafe inline. So that means you are relaxing the restrictions. I would have seen the previous page, by relaxing what all things can happen. This is a primary way of exploiting excesses, and you are loosening it up. So that reduces CSP effectiveness. So solution 3 is CSP2 introduce script whitelisting features. So script whitelisting feature, there are two types of script whitelisting feature. One is nouns based, another is hash based. So the whole idea is to identify the valid JavaScript with an injected JavaScript. So how we are doing that? You're using a script whitelisting. So the first option is noun. So what you're doing is inside the script you put a random nouns. Nouns is an attribute, and you put the nouns along with the HTTP policy and pass it. So the attacker cannot do this because they cannot add these random nouns into the CSP header. In that way, attacker cannot exploit this. So the problem here is for every page generator, we need to create a new nouns. So, based on your site architecture, it may or may not be possible. And another option is hashing. So hashing is basically you take the script and create an hash and stick the hash into the CSP policy. So in that way, you're whitelisting the script. So the problem here is every time you make changes to your JavaScript, you need to recompute the hash and place it on the CSP header. So here is how the hash is computed. Like you take the content of the script, you create a SHA-1 or SHA-256 and go into base 64. That's it. So what are some of the common attacks and how CSP can help to mitigate it? The first thing is content scripting, cross-site scripting. So it prevents from being exploited, the cross-site scripting. However, it does not fix the cross-site scripting, so you need to really differentiate between these two. So you still need to use your common remedies, what I mentioned, like input validation, output encoding, but this is an additional layer of protection. And it is also helpful in unapproved third-party beacons, tag, and content. So you probably add some trusted third-party tags in your application, right? So you can use CSP to whitelist those tags. In that case, it will stop this third-party from piggybacking fourth-party tags. So it's a very good tool. And also have stricter control on what these tags can do on your site. Packet sniffing, very interesting thing. So you can also use this CSP policy to enforce HTTPS and completely remove the mixed content warnings kind of thing. So you can make use of this. Click jacking, use frame ancestors to specify valid parents, so whom can frame your page. For example, login page, you don't want someone to frame your login page, right? Something like that. So this is an alternate option to X-frame option. Probably you are aware of this option. And the next one is block unwanted plugins. So if your application accepts some plugins, and if you are certain that you only accept certain type of plugins, like I only accept PDFs, for example, but no other plugins are accepted. In that case, you can whitelist those plugins. That way you can reduce attack surface area. So now, if you want to deploy CSP, then we need to also understand some browser behavior, because first thing is feature completeness. So we have CSP1 and CSP2. So not all browsers are supported CSP2. For example, like if you want to use form ancestors, so actually it's a part of CSP2. It is not supported in older browsers, and Safari and Edge. So in that case, you need to aware of that. It is not 100%. And implementation disparities. So we have a standard, but implementation slightly varies between browsers. For example, like so for unsafe eval in Safari, even though it flag a violation, but it never send a violation report to the report URI. Things like that. So there are some disparities, some minor things. Some differences between implementation of the policy on different browsers. The mobile browsers that include tablets, they are behind compared to their desktop counterparts. So most of them support CSP1, but even the Chrome and Opera in the mobile, they don't have the CSP support yet, at least when I tested last time. So now we get into another section. So CSP deployment. So now we learned about CSP, and now we are going to deploy CSP. So this is a kind of how you start with. So most of the people have trouble with coming with the initial policy because they don't know what is the initial policy. So the recommendation is ideally get some whitelisted, get some identified domains you trust essentially and whitelist it. And you can come up with a policy, something similar to this. It's just as an example. You can put your trusted domains, trusted whitelisted domain here along with this. This is a kind of a initial policy you can start with. So now how do you test it? So one way is you need to make changes to your application and test it. So that is kind of time consuming and get a lot of effort. So you can test CSP without making any code changes. So there are some browser extensions available to test this. So one of the testing tool is Casper, it's written by my coworker Stuart Larson. So that's a very good tool, basically. So you can test the policy, and let's see how we can test it. So what you have to do is go to Chrome Store, install the Casper. There are other tools also, and you get into your page where you want to apply the policy. Open Casper and put your policy in the Casper. So what it does is, whenever you visit the page again, this policy will be applied to that page. So now you go to your favorite application. I chose gemini.yahoo.com. And this policy will be applied to the page. And if you go to the web console, you can see some violations. So I'll take two violation example. Like here, it says refuse to load the script. You're trying to load this page, is trying to load a script from this location. So how do you fix it? There are two ways. One is either whitelist this domain. If you trust this domain, this link location, then you whitelist it in your policy. Or the other option is take out the JavaScript and put it into the same domain. So that's how you solve the problem. And the next one is refuse to execute inline script because it violates the following CSP directive. So that's related to inline JavaScript violation. So how you solve that? So we already talked about how you solve inline JavaScript. So you either use externalize the JavaScript, or you can use nouns or hash based script whitelisting. And the third option is relax the whole restriction using putting unsafe inline, which is not recommended, but that way you can remove this violation. So this is a kind of rinse and repeat. So you need to do the rinse and repeat this effort or for some time, and until you come up with some policy. So once you have the policy, you can deploy it in your production. So let's talk about how we can deploy it in production. So in the way the modern applications are built is using CI/CD. So you build your application, you check in your code that get CI/CD. You build the application as part of CI/CD process. It also go through some testing and finally get deployed into production. So that's a kind of typical flow these days for all modern applications. So there's another tool called CSP Validator.js. So it's a useful tool basically to detect kind of misconfiguration. If the page got out of sync with the policy, like the policy and the page are kind of different things actually. So you're setting a policy, and let's say you are adding some more contents into your page, and this tool actually can detect that. Basically, try to load the page and apply the policy and see any kind of misconfiguration, and it will stop the build. And the developer has to fix it. It can continue. It is not for detecting any attacks, but this tool is mainly used to detect any kind of misconfiguration in a page before it hitting the production. So it's a very useful tool. This is a very simple tool. It's a phantom.js based script. I just take the URL, apply the CSP policy, and spit out whether it has any kind of violation or not. So you are deploying your application to production. Now, what's next? So your user access your application. Let's say your application contains some kind of web vulnerability, and attacker is trying to exfiltrate data to evil.com. So what will happen? So I assume you have a relatively restricted policy. That means the browser will stop exfiltrating data to evil.com, and it also report a violation. And the violation will be reported into your endpoint, which is specified in the report URI. So in the report URI, basically you can do some kind of analysis, but it's very challenging. I explain you shortly why it is very challenging. But ideally, you can get the report. You can use the report, identify some injection attack, content injection attack happen in the real time, and you can proactively fix it. But in reality, what we encountered is we got our whole reporting endpoint got clogged with browser extension violations. So then we found some, we thought, okay, let's look into it. Then we chose one browser extension and tried to install it. And when you try to install it, this is what it's saying. This extension can read, change all your data on website you visit. This is a Chrome warning, actually. So essentially, the extension can do everything, essentially. One thing I really want to talk about extensions, they have more privileges and permissions compared to a regular web page on your host. So this is a code which I got as part of extension JavaScript. So you clearly say that this file loaded in every web page, and all we do is inject the JS tag to OD itself. So basically, they're injecting some JavaScript to every page you visit. So this is a code as part of the extension. So now what I'm doing, I'm going to visit a web page. I'm going to visit at csptester.io. So the csptester.io contains already have a policy. And let's see here, I open a web console, you can see that script actually mentioned in the previous slide got injected in the web page. So the script is actually getting injected. So this won't trigger any violation because by default, CSP is exempted from browser extensions. So that's the reason it won't complain about it. However, here you can see it is trying to load a script from outside. So there are two things here. One is injecting the code. It won't fire any violation. But the next thing is it trying to load a script from a different location, which is different from self. So that will fire a violation. You can see here, CSP directive default SRC self. So it refused to load the script. So that's how we are getting a lot of extension violations, because it's injected a script trying to load some external script into the DOM. That actually fires the violation. So to sum up, extensions are considered as part of trusted computing base. It's part of your browser itself, they consider. So it can interfere with your web application by injecting ads. So injecting ads is a big problem because when you visit a site, this ad injection extension can put the ads on top of your web page without the site operator's permission. And sometimes they overlay it, or they just remove the actual ad with their ads, all sort of things. And the other one is malware and exfiltrate user information. In the past, we have seen Chrome extensions which are stealing user credentials. And it can even alter CSP header itself. That's another thing. So the CSP header, whatever you said, you can actually modify it. So that's another thing, interesting thing. And even if you are installing some extensions, it may contain excessive vulnerabilities. Even the extensions are trusted, that doesn't mean that everything is good, because it may also contain excessive vulnerabilities, and it will be much severe if you have an access on extensions, because they run in higher privilege mode compared to a regular web page, and they can access all web pages which you visit. And it generates large volume of CSP reports. It basically clog your reporting endpoints. And also, because of this large volume, in detecting the injection attack has become extremely hard, because it's very hard to identify a browser extension violation with a real injection attack. So this is a CSP violation resource-specific distribution of violations. So you can see most of them are 58% of the reports are a violation of script SRC. And the next one is AJAX calls like connect SRC, and the third one is frame. So this is a kind of a general distribution of resource-specific violations.
What's the source for this?
The source is mail, Yahoo Mail. We run as a report volume mode for some bucket. Yeah. So we receive millions of reports every day, actually. So I talk about CSP now. So what is not so good side of CSP? So you need to really understand when we talk about CSP is good for content injection attack. So it is partially true because it is mostly for cross-site scripting, but it won't solve other content injection problems like SQL injections, shell exec, or other server-side injections. So you need to really understand the limitation because you cannot do anything on this. And loose policies make it CSP less effective, especially if you are doing unsafe eval, those kind of things, or you only specify whitelist for only certain resource type. That means that also make it less effective. And the browser extension, they can override CSP policy. They can essentially modify your CSP policy, add it, remove it, all sort of things. So it's less effective against malicious extensions. So if the extensions are very smart, they can actually remove the extension CSP header altogether. In that way, you probably not even getting any violation reports. It's an arms race kind of thing. So right now we are getting a lot of reports. Maybe the extension, they may become more smart, then started removing the CSP headers. And in that case, you probably have no clue about what is happening with your application when it's running on your browser. So whitelisted locations are fully trusted. So if you are operating a large website, then probably you need to use some CDNs, right? CDNs are kind of a shared infrastructure, share a lot of assets owned by different companies, right? So now if you whitelist a CDN, that means you are whitelisting the whole domain. Depending upon the way you whitelist, it can be dangerous because we are just saying cdn.com or star.cdn.com. That means all the contents is part of the CDN you are trusting, but actually you cannot trust that. So you need to really aware of that and use some mechanisms like if you have a separate subdomain, the CDN, then you need to say the subdomain.cdn.com, or you can also use path mechanism to isolate and protect your assets. So let's talk about CSP best practices. So the first thing is maintain code hygiene. So you need to externalize the JavaScript and style out of HTML and keep it in separate files. And use JavaScript event handler rather than embedding into HTML. And the second one is automation. Automation helps you a lot because once your HTML file go out of sync, then this is a tool can use this to detect it. For example, down the line, you have a policy, everything works fine. Down the line, a developer add some HTTP content, but actually your application is everything on HTTPS. So this application can detect mixed content warnings, or you are adding some third-party tags without whitelisting the CSP. This tool can detect that. Always use stricter policies. Use HTTPS scheme always. That way you're making sure that your application is everything on HTTPS. So the other day somebody was asking, what is the difference between this with STS or HSTS? So HSTS is mainly applicable for a particular domain, but if your page contain a lot of page load resources from multiple locations, that may not have HSTS. In that case, it won't be effective. Use path. So path is a feature which added as CSP2 is a very useful tool because especially if you are using some CDNs, you can restrict a whitelist based on the path. In that case, only the assets loaded from this path is whitelisted. If any other asset, for example, .com, something else is not whitelisted. So it's a very useful tool. Avoid wildcard is possible because same way like CDN case, like you can have any kind of subdomains or Tumblr, any those kind of things. There are many cases where this is not a good idea. So enable reporting even on enforced mode. That is also very important. So that's how you learn how your application work in browser. So you expect your application work in certain way, but actually in the reality probably be completely different. One of the things is, let's say you have a dependency on a JavaScript framework which you hosted somewhere else. That can pull another JavaScript which is hosted elsewhere. So it's kind of a chain reaction. is one script load another script kind of thing. So you absolutely have no idea about how your applications are behaving. So this kind of CSP and some kind of reporting can really help to understand how your application work in the browser. CSP, what else you can do? So we found that we're getting a lot of violation reports. So one thing you can do is you can scan violation URLs for malwares. That's another interesting thing. We can use some virus total or some other tools, and we can pass the URL and see it is hosting any kind of malware. In that way, you can detect your user is kind of compromised or not. You get some idea about that. That's an interesting thing probably you can use. Detect injection attacks in near real time. So that's another thing. So if some injection is happening, some content injection, some attacks are happening, you can detect if you have a reporting endpoint enabled. It's very challenging right now because it's a lot of violation reports are from browser extension. So it's hard to distinguish between real injection attack with browser extension violations. And threat intelligence, so you can use as a kind of company-wide kind of threat intelligence, you can use IPs and URLs for other purposes kind of thing. So I'll talk about CSP testing tools. So CSP Tester.io is a tool which you can use to test your policies across different browsers. And you can also use to learn how CSP works. So it's a very useful tool which we develop and open source. So I recommend you take a look. And another one is a CSP validator. You can use it, you can modify it in whatever way and deploy it in your CI/CD. That will check for any kind of CSP misconfigurations. So Chrome browser plugin is also a very useful tool if you want to initially come up with some policy. It's a very useful tool. You can create a policy without making any changes to your application and can do much more than that. So I'll give you a brief demo on CSP Tester.io, how it looks like, how it works. So this is an app where you can, you can place your HTML code here and you can put your policy here. So what will happen is your HTML will be rendered and applying the CSP policy. So you don't have to you don't have to really write HTML code. There are a lot of pre-written tests available. So if you go to the web CSP test, there are a lot of tests available for both CSP 1 and CSP 2. So if you want to just learn how CSP work, you can select one, like you can select view here, and that will put your CSP the content here. So what you can do is this is a policy. You can put the policy here. So the CSP policy in this case is default SRC none, means your application is self-contained. But if you look into the application, you can see there are some links, external links. So let's see how it works. So I'm going to submit it. So it will open a new tab and render that HTML page in a frame, and it will also have another frame which basically report all the violations. So it's a very useful tool because if you want to test, if you have a developer web console, you can test it, but there are many cases where the mobile web and all web console probably won't be available. In that case, it's a very useful tool where you can just get into your mobile and see how it works. So you can very easily know that what feature is supported in which browser. So you just open it in your favorite browser and see how it behaves. There are a lot of CSP2 tests also here. So frame allowed, frame blocked, lot of tests here. And here you can see image allowed, image blocked. Yeah. So please take a look. This is very useful tool. You can either learn and you can also test on different browsers and see how it behaves. And the next one is CSP Validator. I will show you how it works. it's a phantom JS script. So I'm trying to run a phantom JS this script. Oh. Can see it? Okay. So the CSP validator, I'm just running on URL CSP Tester.io, which contain a content security policy self. So let's see how it goes. So you can see here there are no violation. Okay, and let's check what is returning. So it's returning 0, means there are no violations, good to go. So if you are setting the CI/CD, then when you get a 0, that means you are good. You can continue with other tests. Let's try with some other CSP test. I'll try deploying this. So I'm running a test which actually generates some violation. So it's the same test. So I'm taking the URL, okay, and I'm placing it here. And oh, okay. Basically 0. Some shell problems. Essentially, it's returning 0. So now I'm running with a page which contain violations. Let's see how it works. So you can see here there are some 3 violations. Here is a violation, blocked URI. There's another violation, is another violation. And actually it returned 2, means there are some violations. And all these violations, you can see it here in the web page. So all these violations. So it will detect the violation and report it. So it's very good if you have, if you want to detect any kind of misconfigurations. All right. So that's all about the demo. And now to summarize. So CSP work great for forcing content in HTTPS. So if you want to make sure that you clear out all the mixed content warnings, if you are an HTTPS shop, then you can use CSP to make sure that all your contents are on HTTPS. Very good, effective tool. The next one is protection against clickjacking. So the frame ancestors is a very useful tool if you want to use against clickjacking. It's not going to have any other issues. And ability to exclude unwanted plugins. So plugins, like if you don't want to run Flash, or if you don't want to run Microsoft Silverlight, those kind of things, you can exclude it. You can also only allow the plugins what you really support, like PDFs, example. Cross-site scripting is a primary, CSP is primarily for detecting cross-site scripting or mitigating cross-site scripting. However, it's less perfect, mainly because of browser extensions. I explained in detail why, what are the problems associated with browser extensions. Loose policies, we often tend to put loose policies, even if you look into all the policies set by major providers, it's relatively loose because the existing application require a lot of rework to comply with CSP. But if you are developing a new application, I would recommend you to put in enforce mode and tighten the policy. And unsupported browser, that's another thing. But these are kind of temporary in nature. But going forward, I'm really hopeful that CSP will be a very effective mechanism to fight against excesses. But this is a kind of interim state where it is less effective, but it is not bad. It's improving, certainly. Ads block third-party tags from piggybacking fourth-party tags. You can really control it. And reporting is very effective or valuable feedback mechanism, basically to detect excesses or real injection attack happen on your site, and also detect adware, malware kind of extensions. So it's a very useful tool, at least for now, until they started ripping out all our CSP headers. It is not a solution to prevent other injection attacks like shell, SQL, and LDAP injection exploits. So overall, it's very promising, but we are not reached to a state where it's really getting more effective. But I'm hopeful that this will be a very good tool. We'll have a better, more effectiveness going forward. With that, I'm ending my session. Any questions? I think we have just 1 minute. Yeah.
So how does this work with some modern trends like real-time bidding for advertising networks? Is there just too much churn now for websites that support real-time bidding to be able to define what the allowed choices are?
So most of the time, your ads will be placed on iframes, and many times it's not practical to whitelist your those ads because you don't know from where it is coming from. So from that perspective, you cannot really do that because let's say if you know, okay, this is coming from 100 different places, you cannot put 100 locations in your CSP header. So that is not going to work. However, if you know that, okay, you only add some tags, some beacon tags, or something like you're adding some frames of a third party kind of thing, that you can control. So for advertising, you just isolate it. That's the best way. But still, if you know that from where your ad is coming, you can control it, depending upon your use case. Yeah. Any other questions? All right. Thank you very much, and have a good day. Yeah. Bye-bye.